Good evening and welcome to this session. So in this session, we will be solving GATE 2017 mathematics. And here, since the exam is approaching, so all of you must be tensed. So this video will serve as a purpose to secure your complete revision of the course. And if you have solved the paper nicely, then I'm sure you will enjoy it. If you have not solved, still you will enjoy it because there are going to be multiple tricks and shortcuts for solving GATE problems. And here we begin. I've tried to keep the things as simple as I could. So let's begin without any delay. So here you're given a vector space. It consists of all polynomials of degree at most 2. Okay, and there is a functional f from vector space to real, a linear functional such that f of 1 plus x is 0, f of 1 minus x square is 0, f of x square minus x is 2, and they want f of 1 plus x square. All right. So what we could do is, since this is a vector space of degree at most 2, what we can do is we can consider this, what we need to find out, as a linear combination of these three vectors which are given, plus some beta times 1 minus x square plus some delta times x square minus x. Now we simply need to compare and find out these alpha, beta, and delta respectively. That's all what we need to find out. So instead, I'll simply do this: alpha plus alpha x plus beta minus beta x square plus delta x square minus delta x. So just to equate them, I'll keep constants together. So alpha plus beta will be together and all the coefficients of x together. So that will give me alpha minus delta x and plus it will be minus beta plus delta x square. Okay. So if you compare, okay, what you get is alpha plus beta is 1 and alpha minus delta is again 1 and minus beta plus delta is also 1. Now, rather I'll solve these two problems and see what I get. So since alpha plus beta is 1 and alpha minus delta is 1, so rather I subtract it. So this becomes plus, again minus. So this gets cancelled. I get beta plus delta equals 0. And I have minus beta plus delta equals 1. So this gives me 2 delta equal to 1. That means delta will be half. I got delta to be half. And from this equation, beta gives me minus half. And now use one more condition to find out alpha. So alpha plus beta equals 1. So alpha will be 1 plus half. So alpha will be 3 over 2. I found alpha, beta, and delta. I'll substitute in this formula. So in this equation, not formula. So that gives me 1 plus x square equals alpha is 3 by 2. And then 1 plus x and plus beta is minus half, not plus, it is minus half. And then 1 minus x square plus delta is half, and then x square minus x. Now I'll take the advantage of f being a linear functional, so I'll take f. Okay, so f of 1 plus x square will be equal to, and since f is linear, so I have the liberty of taking constants out, and this will again help me here also, and that I'll get f of 1 minus x square plus half of f of x square minus x. And just to being fair with us, GATE authorities have given all these values to be 0, and this value 1 minus x square is again 0, and this is half times f of x minus x square is 2. And we get a nice equation that gives me 2. So the answer is 2. Well, go for the next one. So here is another question from linear algebra. So A is a 7 by 7 matrix. So that 2a square minus a4 is identity. A has two distinct eigenvalues with GM of each eigenvalues to be 3. So they want the total number of non-zero entries in the JC form. This is Jordan canonical. And for this purpose, let's consider A to be a 7 by 7 matrix. So let's consider you have A and it's a 7 by 7 matrix. Okay. And it has got two eigenvalues. So what I'll do, in fact, I'll make a column, eigenvalues, okay, and their AM and their GM. It's algebraic multiplicity and geometric. So A, I'll take, since there are only two eigenvalues, okay, A has only two distinct eigenvalues, and even they haven't given the eigenvalues, so I'll assume that the eigenvalue of eigenvalues are lambda1 and lambda2 without actually finding the eigenvalues even. Suppose the eigenvalues are this, all right? So it's GM is again 3, and here also GMs are 3, they have given, right? Since we are already given the geometric multiplicities. So since we know that AM is always greater than or equal to GM, so it's a 7 by 7 matrix. The only possibility for this is, let's see, suppose AM can be 4, 5, 6, or 7. But the thing is that if one of the value is 4, then the remaining, the lambda2, this has to be 3. And if it is 5, then this eigenvalue forces us to be 2, because 5 plus 2, it should match the AM, okay? The total eigenvalue. See, A can have at most 7 eigenvalues. And since 5 eigenvalues correspond to lambda1, lambda1 takes only 5 values. For lambda2, we have got 2, but this is again not possible, because in that case, if 2 is the AM, then GM is 3, which is not possible. So only ideal choice is that 4 and 3, okay? So either here AM can be 4 or 3, here also. If AM of lambda1 is 4, then AM of lambda2 will be 3. And if AM of lambda1 is 3, then AM of lambda2 will be 4. So these are the only ideal choices that I have. Okay, only choices that I have. And now, can we construct a JC block? So the let me consider the JC block. So let's say I have a 7 by 7 matrix. And now for this, the corresponding to lambda1, there should be 3 blocks. So I have to consider one of the cases. Okay, you consider this one, you get the same result. Even if you consider you get the same result, because it won't affect in any way the Jordan canonical form. So rather, I'll be taking this one. Okay, so we'll consider this case and find the problem. Okay, so in that case, suppose you're saying the eigenvalue of lambda1 is 3. So in that case, we should have 3 blocks. And since the AM is 4, so the AM is 4, so we have to distribute 4 in such a way. We have to distribute 4 in such a way that there should be 3 blocks, and addition of them must be 4. So we can take 1 plus 1 plus 2. The only choice for this. Right? That means one Jordan block corresponding to lambda1, and again lambda1. So see, you get here 3 blocks. GM says that there should be 3 blocks. Okay, because GM is 3, so there should be 3 blocks. And since the AM is 4, so we want only 3 blocks. So we have to distribute this 4 in such a way that we get addition 4, and there are 3 blocks. So corresponding to lambda1, I'll have 1 block here, and then lambda1 here again here. And for this, I'll be having a different blocks that will be lambda1, blue 1, and then 0. So I got 1 block, 2 block. This is over. And now for lambda2. Lambda2 says that again GM is 3. So again there should be 3 blocks. Again there should be 3 blocks. And if you have taken AM to be 4, okay, then ultimate thing is that its GM should be 3. So if AM is 3, GM is 3. So the only choice is that you have to take 1 block only of order 3. Okay, sorry. Only ideal choice is that you should have a 1 block only in that case. So what we could do is just make a 1, 2, 3, 4 rows are involved, and right now I have only 3 rows. So it will be lambda2, 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 and for the JC form it should be 1, 1, and remaining them should be 0, and they will be 0. Okay. The ideal choice is this. And now if you see, then how many non-zero entries are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I guess I made a mistake here, I think, because it is not correct. See, yeah, we spotted the mistake. The GM is 3, that means there should be 3 blocks. And here I have only 3, AM is 3. So we have to distribute 3 in this manner, 1 plus 1 plus 1. Now see, there are 3 blocks of 1 order. So this will not be a 3 by 3. In fact, it should be a single block. So that will be lambda2, and lambda2. And if you count all the non-zero eigenvalues, so they are 1, 2, 3, 4, 5, 6, 7, 8. So answer is 8. So there are 8 non-zero eigenvalues. we did not take help of this equation because there is no guarantee that this is the characteristic polynomial. It is nowhere written. So I did not use this. Rather, I assume that there are two eigenvalues, lambda 1, lambda 2. Even if you solve this equation, you are sure to get only two eigenvalues for sure. Right. In case you don't believe, wait, let me calculate. I hope you are thorough with the DJC block. So just for the verification that whether it has only two eigenvalues or not, we will just take a simple thing. So let's say you have here 2x square minus x power 4 equals 1. And if you try to solve this, so all you can get is, it will be here x power 4. I'm taking everything there. It's minus 2x square plus 1 equals 0, which forms a perfect square of x square minus 1, the whole square equal to 0. So you got only eigenvalues to be square equals to 1. This implies x equal to plus minus 1. Okay, so we have got only two eigenvalues. The question was nicely framed. We now solve it for number 3, and it has something to say with the complex analysis. And here we have got a function f of z to be x square plus y square plus 2xyi, and g of z to be 2xy plus I times y square minus x square. Then in C, they want whether f is analytic, g is analytic, or none of them are analytic. Okay, so just to solve such kind of problems, we basically call our Cauchy-Riemann equation. Okay, we'll consider the Cauchy-Riemann equation. Okay, which is ux equals vy and uy equals minus vx. So just if you notice, then ux equals vy. That means this is my u component, the real part, and this is my imaginary component v. Okay, so to satisfy the CR equations, we need to have ux equals vy and uy equals minus vx. So that means I'm saying that if I differentiate u partially with respect to x, this should be equal to vy, and if I differentiate u partially with respect to y, I should get minus of del v over del x. But if I look at the function f very carefully, then there is no minus. That means this quantity is not going to satisfy this thing, since there is no minus. So f is not analytic. It is clear just by looking at this equation, because it is all plus. Okay, and you cannot get minus just to satisfy this inequality. So this f is not analytic. Or we will verify for g, and for g we have u equals 2xy and v equals y square minus x square. So ux equal to 2y and vy equals to 2y. Oh, that's true, and it is equal 2y equals 2y everywhere. And now differentiate u with respect to y, so you get 2x, and differentiate v with respect to x, we get minus 2x. So clearly it says that ui equal to minus of vx. So your equations are satisfied, and these equations are satisfied everywhere. So g is analytic. So here in that case, f is not analytic, but g is. Okay. All right. Now we got another one from the complex analysis thing. So here we have they have given a Lorentz series, and for this function, and they want the a minus 2. That means a negative coefficient, a minus 2. That means what? I'll get somewhere a term like this. Is it minus 2 square? So they want this coefficient. What is there? Okay. And to solve this problem, we will use a nice formula which we already have from the residue theorem. So I'll be writing this. The coefficient, to calculate this a minus k, you can simply use this formula. This will help you a lot. So 1 upon n minus k factorial and limit z over tends to z no. Okay, it will be d n minus k over dz power n minus k of d z minus z naught power n times my f of z. Okay, and here if you see, then k is 2, and if you are wondering about this n simply stands for the pole order of this pole. So z equal to 2 is a pole, because it's, if I put 2 in the numerator, it's not becoming 0. So that means, and if I take the limit as z tends to 2, this limit goes to infinity. So that means z equal to 2 is a pole, and it has order 3. So n equal to 3. And I want a minus 2. So k is 2. So a, it will be 1 upon 3 minus 2 factorial and limit over z tends to z naught is 2. Okay. And then d of 3 minus 2, which is 1. That means it's only 1 times we need to differentiate. So d over dz of z minus z naught power n is 3. And then I have my function, that is z power 4 plus z power 3 plus z square upon z minus z naught power 3. Oh, I'm sorry, it's not z naught. Well, that looks very strange. Z minus 2, z minus 2, this gets cancelled nicely. And I'll just differentiate and substitute the limit. Well, we have the nice equation of 3 minus 2 1 factorial, that is 1. So 1 is the most ignored thing in the problem. So limit z over tends to 2, and now I'll differentiate this quantity once. So that gives me 4 z cube plus 3 z square plus 2 z. And all I need to substitute is just 2. And that gives me 4 into 2 cube, that makes it 32. And 2 square into 3 will make it 12. And 2 into 2 will make it 4. And this addition total takes it to 48. So the answer is 48. Yeah. And now this was coming from a real analysis, and they are talking about the convergence, pointwise and uniform convergence of this function fn. Okay. So we will inspect the pointwise convergence first, because there is one option for pointwise C. It says that fn does not converge to f pointwise to some function f pointwise, and it says that fn converges uniformly f on 0, 1. And here it says fn does not converge to f uniformly, but it has a subsequence which is uniformly convergent. And in the option D, they have given fn converges to f, but does not have a subsequence which will converge uniformly on 0, 1. And to do this, we will inspect the pointwise first. So at x equal to 0, my limit n tends to infinity fn of x. Okay, this makes it limit n tends to infinity. Since x is 0, this entire limit becomes entire function becomes 0, so I get 0. So for x equal to 1, I have limit n tends to infinity. Fn of x gives me limit n tends to infinity. X is 1, so I'll be getting just 1, simply 2 upon 1 plus 1 minus 2n square. And since there is no n in the numerator and this n is taken to infinity, so this entire quantity goes to 0. Okay, and between 0 to 1, the function will behave as usual. It will again tend to 0, because if you take any x between 0 to 1, the ultimate thing is that n here is playing the role. So basically this n will take you to 0. So this again tends to 0. That means what? We have a limit function. That means my f of x is 0 for all x belonging to 0 to 1. This implies what? That fn converges to f pointwise. Okay, so that means it is guaranteed that fn converges pointwise. So simply means this option is incorrect. C option is incorrect. It says that fn does not converge to f uniformly, pointwise even. Okay, single arrow stands for pointwise, double arrow stands for uniform. So we got a pointwise limit. That means fn does not converge to f pointwise, but we got one. So this C option is incorrect. And now we will inspect the uniform convergence. And to inspect the uniform convergence, we will take help of the MN test. So MN test says that you have to find out the supremum of x over 0 to 1 and modulus of fn of x minus f of x. And clearly, I have to find out the supremum. So supremum over 0 to 1, what is my function, is 2x square upon x square plus 1 minus 2nx. 1 minus 2nx square. Okay, square. And now to handle this, since I need to find out the supremum, rather instead of finding the supremum directly, I'll take this entire quantity to be some un. Okay, so un of x is 2x square upon x square plus 1 minus 2nx square. Okay, so just differentiate it, un dash of x, and equate it with 0. Okay, take the derivative of this and equate it with 0, and I just need to check where is the critical point. So at that critical point, my second derivative shows that this will be a maximum, okay, in between 0 to 1. So a rigorous calculation. Okay, let me do it. And dash next. Let's see what I'm getting here. So this entire quantity here becomes squared. This whole quantity will be squared, and this will again come in the numerator. So it will be 1 minus 2nx squared. And derivative of 2x squared is 4x, and then minus 2x squared will remain as it is. And here there will be a big game, and it gives me 2x minus 2n instead of 4n into 1 minus 2nx. 1 minus 2nx. Oh, I'm sorry for this problem. And now I'll equate it with 0. So this entire quantity goes to 0. And this numerator gives me x equals 1 by 2n. And for x equal to 1 by 2n, okay, you get un mn. So mn at x equal to 1 upon 2n gives you 2 times 1 over 2n square, and then 1 over 2n square plus this becomes 2n, x is 1 upon 2n. So 2n gets cancelled. So you get 1 minus 1 becomes 0. So there is no term here, in fact. And if you see this, then this clearly gets cancelled. And as n tends to infinity, so mn tends to 2. So by mn test, the series fn sequence fn does not converge to f uniformly. Okay, so it is not uniformly convergent. And now, if you see at this option A, it says fn is uniformly convergent. It is wrong. And now here comes the problem. It says that fn converges to f pointwise, but does not have a uniformly convergent subsequence. So in case this n is playing role, so if you take any subsequence, this n is not going to get dissolved. So ultimately, if you look at option B and D, option B says that fn does not converge to f uniformly. That is fine, but has a subsequence. So I'm saying that if you take any n, let's say the subsequence will look like f2n or f3n, fn square. There can be any subsequence, but for any n, you'll get the same behavior. So that means fn cannot have a subsequence which will converge uniformly. So this D option will be true because fn is pointwise convergent and it does not have a subsequence which converges uniformly. And that finishes your solution. Okay, I'll erase this part because it belongs to some different party. And here I have calculus. So let's handle it. And now if you look at this problem, then it clearly shows that there is C, there is curve x square plus y square equals to 9, be a circle in R2 oriented positively. Okay, it's counterclockwise. And here I need to find out the 1 upon pi and this big integral. So just to handle this, I'll take help of my Green's theorem. Okay, in Green's theorem, it will have m dx plus n dy that shift it nicely to double integral over domain D and del m over del x minus del m over del y, then dx, dy or dy dx. You can apply, in fact, Fubini theorem and find out. Now, our m is 3y minus e power cos x square, and n is 7x plus under root y power 4 plus 11. And now del m over del y, it will be simply 3, and del n over del x will be simply 7. So now this integral becomes 7 minus 3. That gives me 4 times dx dy over the region D. So it will be simply 4 times double integral over region D and then dx dy. And if you look at this double integral clearly, and since there is no f here, so this stands for the area of the circle. So we know that area of circle is pi r square. Pi r square. So r square is 9. So it will be 9 pi. So that gives me 36 pi. But I have got here 1 upon pi. So I'll take this pi here. I'll divide this. Okay. And then this pi gets cancelled. So answer would be 36. Yeah. Yeah. So we got one problem from Lebesgue measure. It says that there are two statements given. Statement P says that there exists an subset of R whose Lebesgue measure is 5. And Q says that f is a continuous function on R, and G is also continuous function. For G, we don't have any data. It says that G is from R to R says that f equals to Z almost everywhere on R. That is fine. That means there are n number of points for which f and g agree together. Then it says that g must be continuous. Well, so at the first appearance, it may see that this q is correct, because we may get the wrong impression that g is from R to R and f is equal to g almost everywhere on R. Then g must be continuous. So to understand such kind of things, we need to produce one function which will discard this or make it true. Because mostly you can't generalize this by taking one problem. You got suppose one function which holds this. That doesn't mean the given statement is true for all f's. So we need a counter example for this. So to counter this thing, I'll generate one function. So let's take, to deal with such kind of functions, we generally deal with Dirichlet functions. So I'll take Dirichlet function. So g of x is 1 for x belonging to q, and I'll take -1 for x belonging to q complement, or you say r excluding q. That's irrationals. R excluding q, right? And now, and define one more function, f. F of x is defined to be, say, 1. Okay, for all x belong to R, in fact. Define it a constant. And now if you see, then f and g are almost, f equal to g almost everywhere on R. That means for every rational and every real, they are all equal. If you see, then g is equal to f. That is true. And f is continuous. Yes, f is continuous. And since there was no information on g, so I took the advantage. It is saying that g must be continuous, but we know that Dirichlet is nowhere continuous on R. So this Q statement is false. Q statement is false. And now for the P statement, it says there exists. That means it is not for every case. So that means there exists an unbounded subset of R whose Lebesgue measure is pi. Well, we can construct an unbounded subset of R whose Lebesgue measure is pi. Instead of 5, they would have given 6, 7, 8, 1.5, 3 by 2, anything. We can construct an unbounded set. So to this purposely, I'll take, let me recall something. Yeah. So I need to construct a set whose measure is 5. So 6 minus 1 will be 5. And since I have to make this set unbounded, so I'll take the intersection with Q. And take this set A to be closed interval 1 to 6 and intersection with Q. Okay. It has got measure of A is 5. Okay. That is fine. So when they would have given 6, you could consider simply 1, 7. Or you can take n number, just intersect with Q, just to make it unbounded. Okay, it's an unbounded subset of R whose measure is 5. Okay, so since the case was for there exist, so this P statement will be true. Okay, and now for this 8th problem, let's it simply says that x cube y square is an integrating factor for this. That means if I multiply this entire quantity with x cube y square, my differential equation will be exact. So I'll rather multiply by taking this term separately. So I'll multiply x cube y square with this quantity, 6y square plus alpha into xy, and n will be again x cube y square times 6xy plus beta x square. And this nice equation gives me 6x cube y4 and plus alpha x4 and y cube. And here I have 6x4 y cube and plus beta x power 5 and xy square. So I just need to differentiate, because after multiplying with the integrating factor, this has to be exact. So del m over del y should be equal to del n over del x. Let's equate them in this line. So del m over del y. So I need to differentiate this function with respect to x. With respect to y. This is m. So it will be, there is only y4, so 4 into 6 will make it 24. So let's write down like this. There is no harm in it. And plus 3 alpha x4 y square will be equal to, now we will differentiate n with respect to x, and that will make it again 6 into 4 times x cube y cube, and plus we need to differentiate with respect to x, so it will give me 5 x 4 and then y square. and we see these things getting cancelled. I'm sorry, this is beta even. There is beta. I forgot to write here phi beta. And if you notice these two very clearly, then this also gets cancelled. You get nice 3 alpha equals phi beta, and making A option true. Yeah, so let's solve this one. It says that x and xt and yt are the solutions of this system, and the initial conditions they have given some x0 is 1, y0 is 1, then they want x of pi by 2 plus y of pi by 2. What it's gonna be? So we will consider, since, well, if you noticed one thing, then x dx over dt is y, and dy over dt is minus x. So what if I differentiate x with respect to t one more time? I have dx over dt to be y. Okay, I'll differentiate it one more time. Okay, so differentiating with respect to t. Okay, so I'll be getting d over x by dt2 equals dy over dt. But I know that this quantity is minus x, so it will be d square x over dt2 equal to minus x, and take this here. So d square x over dt2 plus x equal to 0. Well, now operator method gives you roots to be minus, plus, minus I. So the solution x of t is going to be c1 cos t plus c2 sin t. And once I got x, I can easily just differentiate to get y, because I know that if I get x and if I differentiate x with respect to t, I get y. So I'll simply write down here y of t, and that gives me minus c1 sin t plus c2 cos t. And well, we are now in fact it's the time to use the initial conditions. X of 0 is 1. So if I use this condition x of 0 to be 1, okay, I'll erase this quantity because I have no space here. Okay, so let's consider this thing to be erased because I don't need it. I got the solution, so I'll solve it here. Since x of 0 is 1, and that gives me, so here it will be 1, and sine 0 will be 0, so I got here c1 is 1, and y of 0 is 1. So y of 0 is 1. Just put here at the place of t, put 0, so you get sine 0, 0. This quantity survives, and it again gives you c2 equals to 1. Okay, so c1, c2 have no connection. Just erase them simply because they are 1. So we got c1, c2, and we got our nice solution. What I need is x of pi by 2. So x of pi by 2 will make it 1 from here, and y of pi by 2 will make it again minus 1 from here, because cos 90 will be 0 and sin 90 will be 1. So 1 minus 1 will make the final solution to be 0. So the answer is 0. All right. Now let's consider this thing. What is here? So solution goes here. And now if you notice this problem, then it says y equals to 3 into e power 2x plus e power minus 2x minus e power alpha into x. It's the solution of this IVP. Some IVP is given, and they want the condition on alpha and beta. Well, I'll just write down these two equations, and without even solving this, we can answer this question. I know the solution is given by y of x equal to, they have given 3 e power 2x plus e power minus 2x and minus alpha times x. So if you notice, then this is the complementary function or the homogeneous solution. And here, if we compare with our standard equation, so we get c1 e power m1x plus c2 e power m2x. This is only possible when m1 and m2 are plus and minus 2. That means m square must have been 4. Okay, so m square had to be 4. That means m square minus 4 would be 0. What is m, by the way? It's d2y over dx2 minus 4y equals 0. That means if I compare this equation with this, I get beta to be minus 4. Okay, beta to be minus 4. So if beta is minus 4, there is only one option correct, that is C. Discarding all the options incorrect. So the set of problem is ready from 11. It says G is a non-abelian group of order 125. G is a non-abelian group. The key letters are here is non-abelian group of order 125 in the number of elements in the center of G. Okay, for a non-abelian group, we know one result. Okay, that for a non-abelian group of order P cube. Okay, so number of elements, that is order of center of G, is equal to P. So if we compare, then it's 125 is nothing but 5 cube. So it's like for a non-abelian group G of order P cube, its center must have 5 elements. So answer is 5. It was just a one-liner problem. And even this one, though this looks very strange, F1 and F2 are the subfields of a finite field F consisting of 2 power 9 and 2 power 3 elements respectively. So we know that FPR is a subfield of FPS if and only if R divides S. So if you see, then 2 power 3, okay, is FPR. Okay, it's a subfield basically. So F, it's 2 power 3. That means we need to consider about this 3 and this 9. So 3 divides 9. Yeah, that's true. Okay, so 3 divides 9. That means subfield is possible. But what we need actually is whether, oh, once again, it's 2 power 3 and 2 power 4. All right, but once again, I'm sorry. F1 and F2 are two subfields of a finite field F consisting of 2 power 9 and 2 power 3 respectively. That means what? Is just a moment. This result will be used for the purpose, but the purpose here is different. So I'll erase this result because it is no longer needed right now. We see that 2 power 9, okay? It's 2 power 9, okay? In fact, no, not this one. For 2 power 3 divides 2 power 9. Divides 2 power 9. That means 9 is divisible only by 3, okay? Rest for nobody else. So that means its subfield, okay, its subfield will have order 2 power 3, okay, and for 2 power 6, okay, 2 power 6 is divisible by, I think I wrote the wrong question. It's 2 power 6, okay, not 3. Just a moment, let me check the booklet again. What they are given. Yeah, it is 2 power 6, not 3. So that's what I was making a mistake there. It's 2 power 6, and 2 power 6 is divisible by 2 power 3 as well as 2 power 2, because 3 and 2 both divide 6. So its subfield will have order 2 power 3 and 2 power 2. But what they want is the number of elements in F1 intersection F2. So intersection is this 2 power 3, and it has got 8 elements. So the answer is 8. And now this problem is coming from the functional analysis, and it has an application of Hahn-Banach extension theorem. So here, what is Hahn-Banach extension theorem? If you have read functional analysis, then you must be knowing that I should have a functional form. Let's say X is my space, and I have a functional, say G, a bounded functional, and once again, not this one. Let's say Y be a subspace. Okay, Y be a subspace of X, and G is a bounded functional on Y. If G is a bounded linear functional on Y, then there is a restriction, okay, on F. So that means there exists an Hahn-Banach extension F such that this G can be completed to X. So right now G is just bounded linear functional on Y, so it can be completed to X, and norm of F will be same as norm of G, and then this F will be coming from F will be simply from X to R. Okay, so this F will be our linear Hahn-Banach extension. So here in the place of F and G, they have they have switched the signs. They have given F to be bounded linear functional, and they want G. So that is fine. So we will first show that F is bounded linear functional. So when a function linear function is said to be bounded when mod f of this capital X is less than or equal to some c times norm of x, then f is said to be a bounded linear functional. Okay, so we have to show that this f is bounded linear functional, and we have to calculate its norm. Okay, because I need to, if I calculate this norm of f, there is no need to calculate this norm of g, because I know that by Harmonic extension, norm of g will be same as norm of f. So I'll be getting some conditions on alpha and beta, and this is what they're asking with what will be alpha minus beta. So let's begin with the process. So I'll consider mod of f of x comma y. This is equal to mod of 3x. But since I'm given that it is on R2, so I can split this. So 3 by 2x over 3 by 2x. Now just apply the triangular inequality. It will give me 3 times mod x plus 3 by 2 times mod x. But I know that f is defined on x, and x is a vector space of nonlinear space, and it says that x is equal to y. So I can replace this mod x by mod y here, and taking 3 by 2 common. So it will be mod of x plus mod of y, and this is nothing but my norm. So I got here mod of f of x comma y is less than or equal to 3 by 2 over norm of x comma y. So this implies what? F is bounded, and linear functional they have already given. So f is a bounded linear function. So by Harmonic extension, f has an extension that we call g. Okay, so I'll utilize the next page in fact. So by Harmonic extension, there exists g from x to r such that norm of f same as norm of g. Okay, and this restriction of f was defined from x to y, so a restriction is same as g. So we'll be using these two things, and to find out the norm f. So norm f says that it is nothing but the supremum over x belong to capital S, so that x is non-zero. So mod of f of x upon norm of x. In this manner, I can find out norm f. So that will be given by a supremum over x belong to capital X. Mod f of x is my 3x, and norm of x is my norm of x. Mod of x plus mod of y. So mod of x plus mod of y. Clearly, I know that for x defined this thing, it is clearly mentioned that mod of it will be mod of x can be written as 3 times mod x. This is mod x plus mod y, but I know that mod x is same as x will be same as y. So I'll be getting mod x plus mod x, and this gives me just 3 over 2. So norm of f is 3 over 2. This implies what? Norm of g will be also 3 over 2. Okay, so norm of g will be also 3 over 2. And now let's apply and see what conditions we get on f and g. But since I know that f restriction of f is same as g, so this implies f restriction of f is same as g. This implies 3x will be same as alpha x plus beta y, so that g is equal to alpha x plus beta y. I'm sorry, I did not mention it. Okay, but since I know that x is same as y, so I'll be getting 3x equal to alpha x plus beta x, which gives me nice equation alpha plus beta equals 3. Alpha plus beta gives me 3. And now I need to find out what is the another condition. So I'll erase this part because I don't need it for the time. And in this purpose, yeah. So we got here, I got alpha plus beta is 3. And now I'll also do this, that mod of g of x comma y equals mod of alpha x plus beta y. And I'll be applying the triangular inequality and say mod x plus mod of beta into mod of y. But I know that this mod of alpha is always less than or equal to max of mod alpha comma mod beta times mod x plus, or beta also I'll do the same thing because it is always less than or equal to its maximum. So mod of alpha beta, and this will be mod y, take maximum thing common. So maximum of mod alpha comma mod beta times this will be mod of x plus mod of y. And I see that this is max of less than or equal to mod alpha mod beta, and this is my norm x. So this is my mod of gxy, and I divide by this norm x. So g of x comma y upon norm of x is less than or equal to max of mod alpha comma mod beta. And if I take the supremum over x belong to capital S, so that x is non-zero, this quantity gives me the definition of norm. So this implies norm of f, norm of g, not f, it's norm of g must be less than or equal to max of mod alpha comma mod beta. So I found that this condition is needed. Alpha plus beta is 3. So let me write it down somewhere. Alpha plus beta is 3. This is one condition. And from here, I'm getting norm of g. I know that it is 3 by 2 by Anbanak. It is 3 by 2. Okay. So just let's write down here. 3 by 2 is less than or equal to max of mod alpha comma mod beta. And now alpha plus beta is 3. So from this, we need to find out what is my alpha and beta. So for this purpose, we can apply simple logic and say, what if mod alpha is 3 by 2? Then this mod beta has to be less than or equal to 3 by 2. But if, suppose if alpha is 3 by 2, because maximum is 3 by 2, maximum is greater than or equal to 3 by 2. So I'm taking equality constraint. So if my alpha is 3 by 2, then beta has to be less than 3 by 2. But if beta is less than 3 by 2, this quality will not be satisfied. So in that case, this is only satisfied when alpha is 3 by 2 and beta is again 3 by 2. So alpha and beta should be 3 by 2. So in that case, I get alpha minus beta to be 3 by 2 over 3 by 2, and that gives me 0. So resultant would be 0. So this was a simple application of Arnbank extension theorem. So of 14th and 15th, I have not solved. We will solve some number 16. So if the quadrature rule 0 to 2 f of x, it says that between 0 to 2, my f of x dx is exact to c1 f of 0 plus 3 times f of c2 plus 3 times f of c2. All right. So we need to find out what will be my c1 plus 3c2. So it says that it is exact for polynomial of degree less than or equal to 1. So in that case, I can have the polynomial f of x to be 1 or x. So let us substitute here. So if I have 0 to 2 constant, that means just dx, so it will be c1 times f of 0 plus 3 times f of c2. Since I have taken constant 1, so it will be simply 1. Okay. And f of 0 will also be 1. Oh wait, let me write down in the next line just to create. So it will be f of c2. So this quantity right here will give me 2 and c2 times c1, but f of 0 is again 1 and f of c2 is again 1. So c plus 3. So this implies c1 gives me minus 1. Well, I'm happy now. And now the same thing for x. So that means 0 to 2 x dx will be equal to c1 times f of 0 plus 3 times f of c2. So if you integrate this, then 2 square over 2. Okay, 2 square over 2 will give me c1 is minus 1 and f of 0 will be 0 plus 3 times f of c2 will be c2 simply. And this 2 and 2 gets cancelled. This implies c2 is my 2 over 3. c2 is 2 over 3. And now just substitute here c1 plus 3 c2. So c1 plus 3 c2 gives me minus 1 plus 3 times 2 over 3. That gives me 1. So answer is 1. Okay. So even if you do not know quadrature rule, still you were able to solve this problem. Now, let's solve this one. So I've not written the options for this problem, but I'll simply solve this. Here, the question was to formulate the PDE, by eliminating this arbitrary function. So simply I'll equate with ux, and that gives me 1 plus f dash of xy with y in it, and differentiate with respect to y partially. That gives me again 1 plus f dash of xy, and here you get x. So I need to eliminate this f. So instead I'll multiply this equation by x and this by y. So that gives me x, ux will give me x plus f dash of xy into xy, and I'll multiply this with respect to y. So I get y plus f dash of xy into xy. And all I need to do is just subtract these two equations. And nicely this gets cancelled. And I get x ux minus y uy equal to x minus y. Find out the option which looks like this. Now let us solve this one. So you are given x, x plus x minus y, and x minus y del square u over del x del y minus y times del square u by del y square, and so on. So you just need to compare with the canonical form of this equation that says a uxx plus b uxy plus c uyy plus d ux plus e uy plus f equal to 0 or g. So you get a equal to x and b equal to x minus y and c equal to minus y. We need to find out b square minus 4ac. That gives me x minus y square minus 4 times x into minus y. We'll make it x minus y square and plus 4xy. All right. So x minus y square plus 4xy, which makes it this is x minus y square plus 4xy. If I expand this, I'll be getting x plus y square. And now I should know all three conditions: that if b square minus 4ac is greater than 0, this implies it is hyperbolic. The given PD is hyperbolic. And if my b square minus 4ac is negative, so the PD will be elliptic. And if it is 0, then this becomes parabolic. Okay, it becomes parabolic. So x plus y square, we already know that it is always greater than 0. Okay, it is always greater than 0. But it is saying that hyperbolic along x plus y equal to 0. But if x plus y is 0, this will not be hyperbolic. Rather, it will be parabolic. So only the option is correct. Okay, so it is parabolic along x plus y equal to 0. Okay, so when x plus y equal to 0, this will be b square minus 4ac. It will be 0. So the given PD will be hyperbolic. Parabolic. And 19 and 20 are the problems from topology. And well, I am not well versed in topology, so I did not make any video on this. And 21, 22, 23 are from statistics. So they have to watch a different video for statistics background. I've not solved it. Now, rather, I'll solve problem number 24 and 25 in this video. And from 25 onwards, I have my separate part 2 video. You need to watch that for better reference. So here we go. Now, we need to maximize this. So z equal to 4x1 plus 6x2, x1 plus less than or 8, and 2x minus 3x2 is greater than or equal to 18. So let us solve this. What it is saying, it says x1 is greater than or equal to 6 and x2 is unrestricted. Means there is no restriction over c, x2. So let me solve the problem. And x1 plus x2 less than or equal to 8 is by this line. And 2x1 minus 3x2 is greater than or equal to 18 is my this line. In just a moment, I think I need to expand this, because if this is 6, 8, 0, and this is 0, 8, so this one is my x1 plus x2, and it will be 9. So 9 must be here somewhere, and then it will be 0, minus 6. I think I wrote the incorrect problem. This is 2x1 plus. I'm sorry, just gonna have a plus. It is 2x1 plus 3x2. So here, in that case, you have coordinates are 9, 0, that is this one. And here you have 0, 6. So it will be here somewhere. Let me join these 2 points. And here I get nicely this 2. And it is saying x1 is greater than or equal to 6. So all I'm concerned about is this point. So what is my this point? If I solve them, x1 plus x2 equal to 8 and 2x1 plus 3x2 equal to 18. So I'll multiply this equation by 2. So 2, 2, and this becomes 2 into 8. And subtract them. See what we get, cancel. 2 minus 3 is minus 6x2 equal to 16 minus, it is 16 minus 18 will be minus 2. So x2 is 3. x2 is, sorry, x2 is not 3. I think it's 1 by 3. Okay, x2 is 1 by 3. Just put x by 3. So we get 2x1 plus 3x2 equal to 18. So 2x1 plus 3 into 1 by 3 will make it 18. So 2x1 equal to, it's 17. Oh, something is fishy. What have I written here? Clearly, I think x1 plus x2 is 8 and 2x1 plus 3x2 is 18. This point is 6, right? 6 comma, I need to check which will satisfy. So what if I do this? 6 plus 2 becomes 8 and 6 into 2, 12 plus 3 into 2, 6 is 18. Yeah. So this point is my 6 comma 2. So clearly x1 is greater than or equal to 6. That means I will have this line. And now let us see where the region is. So I'll draw the region by a blue color. So for this thing, we have the origin towards the origin. So that means we have this region. And for this line, we have this region because it is greater than. And it also says that we have x1 greater than or equal to 6. That means for this thing, we have greater than or equal to 6. Okay. So now we see that there is no feasible region actually. Okay, which satisfied all three. So that means we have got only this point to be the common region. It's the only common point. So we have got only one optimal solution. 6, 2 is the only optimal solution. Okay, so this LPP has only one optimal solution. Okay, and this makes option B to be true. Only one basic solution, and that is optimal. And there is one more concept. It says that if you take 2 common here, so you get 2x1 plus 3x2. And since your objective function is parallel to your constraint, so majority of people think that the LPP will have infinitely many optimal solutions, but it is not true. Okay. So this will be a wrong idea to employ. Rather, you solve it by actual method. Okay. Anyway, if you notice 25, then this LPP, it is asking which of the following is not true. And if you read the problem, then I'm sure statement A appears to be true, but no doubt. Okay, it is always true. Because the dual of dual is primal, that is true. So it is true. So we don't have to worry about this. Let's check for the next one. Okay, what it is saying. It says that if primal has unbounded objective function, then the dual is infeasible. Okay. And C is if the primal LPP is infeasible, then the dual must have unbounded objective function. Okay. Dual have unbounded objective function. So even that is not true. Okay. And D is what? D says that if the primal has finite optimal solution, then dual also has finite optimal solution. Yeah, that is true. If your primal has finite optimal solution, then dual must have optimal solution. That means A and B are true. Now, the battle is between B and C. B says that if primal has unbounded objective function, if the primal has unbounded objective function, then the dual of LPP must be infeasible. Yeah, even that is correct. Okay, if the primal has unbounded objective function, then LPP is infeasible. But if the primal of the LPP is infeasible, then dual of LPP must have unbounded objective function. Well, that is not true. It says because of the word must. Because if the LPP is infeasible, then the dual may have unbounded or no solution. So here, in this case, it is saying must. So this option C is not true. So that means this is our correct option. Okay. So we have solved 25 problems here. For the remaining 25, stay connected. Part will be coming soon. Thanks for watching.